Hey guys, it's me again. Just wanted to go ahead and get the notes for the 8.2 covered just because they pretty much go along with 8.1, so you kind of need them in order to do the quick check. So let me go ahead and switch my screens real quick just so you can see what I'm going to be going over. Hopefully my computer doesn't kick me off again. Okay, so for 8.2's notes, we're looking at combinations, which are really similar to permutations. It's just another option in order to calculate number of options that you have. So let me go ahead and make those notes a little bit bigger for us. Okay, so just kind of as a warm up, remember permutations was where order matters. So if you had a problem that said the Miss America pageant awards crowns to its winner, first runner up, second runner up, and third runner up. Okay, so keep in mind there are four people here. Winner, number one, first runner up, number two, second runner up, number three, and third runner up, number four. Four places you're awarding. Okay. If there are 50 states represented, how many different ways can the crowns be given out? Okay, so our N, the total number of things we have to pick from, is 50 because there's 50 states, 50 contestants. Okay, P, this is a permutation. Order definitely matters here. Someone who doesn't get anything is going to be really upset, whereas the winner is going to be the happiest person, obviously, if they won. So, make sure you are using a permutation. And then we're choosing four spots. So 50p4, if we plug it into our formula, 50 factorial divided by 50 minus 4 factorial. We simplify those a little bit. We put those into a calculator, and we should get 5,527,200 ways that those winners can be given crowns. So lots and lots of different ways for winners to be picked in that large of a group of people, which is totally fine. Like I said, big numbers are going to be fine here. You're supposed to get big numbers, it's okay. Um, but something to consider, okay? So let's suppose that each crown recipient was awarded the same cash prize. So you want to find out how many ways there are to choose the cash recipients. Would the outcome be the same? Okay, so if you're giving each person the same amount of money, now granted you are still picking four people, but does it really matter the order that you give that money in? Not really. Okay, so that leaves us to our next topic, which is combinations. Okay, so combinations is how many different ways we can choose things, but the order is not important. So remember, permutation, the order is important. Combination, it's not. The notation is very similar. You have an N in the front, which is your number of items you're picking from. C is going to be in the middle this time for combination, and then R is at the end because that's the number of things you're choosing. Okay, the formula is slightly different. So we're still using our factorial, but it's n factorial divided by r factorial times n minus r factorial. Okay, so be really careful when you're copying things down or when you're typing this into a calculator because it is going to matter. Okay. So to go through a couple of examples here. So it says for next semester, you need 2 elective classes to fill your schedule. The counselor gives you a list of 15 available electives. How many different ways could you complete your schedule? All right, so we have a total of 15 options, right? 15 classes to pick from. So that's going to be our N. Okay, we only have to choose 2 of them, right? So R is going to be our 2. And then typically this is where you're going to ask yourself, does the order matter? Okay, well in this case, no. It doesn't matter if you take jewelry first or ceramics first, okay? It doesn't really matter what the order you take the classes in. You just have to take these 2 electives. So we use a combination here. So we're going to plug those numbers into the formula, 15 factorial divided by 2 factorial times 15 minus 2 factorial. So if we simplify that a little bit, 15 factorial divided by 2 factorial times 13 factorial, our final answer should be 105. Okay, so let me show you how to type this into a calculator and the type of numbers you're supposed to be getting here. So I'm going to go back to my Desmo Scientific Calculator because it has all the buttons that I need. So first thing I'm going to do is type in 15 factorial. Well, just 15 factorial on its own is this huge, 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 huge number, okay? Which makes sense because you're multiplying 15 numbers together. All right, but we need to keep going from that, so we're going to divide. Formula says 2 factorial times 13 factorial. Okay, now notice when I type all that stuff in, it has to go in that order and I have to type in every part. 15 factorial is on top, then my divided sign, 2 factorial, multiplication sign, 13 factorial. Okay, if it doesn't line up like that, this isn't going to work out. But it gives me a final answer of 105, okay, which is what I was supposed to get on my notes slide. Another way you could do this, so I showed you this with the permutation video, there's also a combination button, okay? So if you go down here to, if you see the NPR and you see the factorial, NCR happens to be in the middle, so I'm going to click on that, and then remember you have to type in the N number first, so I'm going to type in 15, I have to put a comma in between my numbers, and then my R number, which in this case is 2. So again, final answer 105. Okay, so multiple ways you can calculate it, multiple ways you can get that final answer, but we have 105 different options or different ways you could choose your classes. Second example, okay, it says the Burger Palace is famous for its 20 topping options. You want a burger with exactly 5 toppings. How many burger options do you have? All right, well, I have 20 toppings to choose from, and I'm going to pick 5 of them. Okay, and you ask yourself, does it really matter that they go on your burger? Not really. You're going to eat it, and it's all going to go to the same place. So order doesn't matter. We're going to make sure this is a combination. So again, I put those numbers into my formula, 20 factorial divided by 5 factorial times 20 minus 5 factorial. Well, 20 minus 5, if you simplify that, that's just 15. So I type all this into a calculator and I simplify. My final answer should be 15,504 options for your burger. Lots of different options. And if you're anything like me, who's super picky and it takes you forever to decide on things, well, that's way too many options. Which brings me to our last example. All right. It says, on your next visit, your little brother joins you. So the kids menu has the same 20 topping options, but they can choose at most 3 toppings. How many burger options does your little brother have? Okay, now the wording here is super important. Okay, it says they can choose at most 3 toppings. Does that mean your little brother is going to choose 3? Maybe he only wants 2. Maybe he only wants 1. Or maybe he's a super picky kid, because a lot of little kids are, and they want a super plain burger with no toppings. You don't know. You have no idea what he's going to choose. Okay? So here's what we have to do. We have to plan on any scenario. All right? So we would have to calculate from 20 toppings, what if he chooses 3? If he chooses 3, he's going to have 1,140 different options. Okay? Let's say he only wants 2. If he only wants 2 out of the 20, he's going to have a possibility of getting 190 different burgers. Okay, let's say he only chooses 1 topping. If he has 20 to choose from and he chooses 1, that's 20 different burgers he could have. Or again, if he's super picky and he wants a single plain burger with absolutely 0 toppings, well, that's still 1 burger he can get. All right. So here's the deal. We don't know what he's going to pick. We don't know if he's going to pick 3 or 2 or 1 or 0. So what we have to do is take all these possibilities and we have to multiply them all together. So I multiply all those numbers together, and your little brother has 4,332,000 options for his burger. Okay, lots of different options. And if you give a kid that many options, his mind's going to explode. So, maybe don't tell him that many options he has, but just try to encourage him to get no toppings, and then he only has 1 burger choice. All right, but that kind of takes us back to our number of how we're choosing things and how we're getting those choices. So remember, combinations is what's going to happen when order is not important. Permutations are when order is important. Again, if you have any questions about things or need help with anything, you can join my Google Hangouts during my office hours at 10 a.m. and 2 p.m. on school days, which are now, I guess, Tuesday through Thursday. Or if those times don't work, or those days don't work and you need some other time to talk, please let me know. It's not like I have anywhere to go. So, all right, well, take care, everybody, and good luck with everything. Hopefully, I'll see you next year.